This is going to be Euclid Book 7, proposition number 8, and let me tell you something, this is extremely hard unless you have me walk through it right with you. Okay? Here's what it says. If a number be the same parts of a number that a number subtracted is of a number subtracted, the remainder will also be the same parts of the remainder that the whole is of the whole. You're probably sitting there scratching your head going, oh my word, what is he talking about? Okay. Just a second here. I want you to copy this. Okay. And the reason I'm going to have you copy this is that when I read this to you, yeah, you're going to need this. That's all there is to it. You're going to need this. So, for let the number AB be the same parts of the number CD. Now, what does that mean? Okay. In this case, we're going to say that, now it doesn't matter what unit of measure you use. You can use centimeters, you can use meters, you can use inches, you can use miles. It doesn't matter. The unit of measure is not important. It's the numbers that are going to be important at this point. Okay? So, we're not even going to talk about units of measure here. We're going to talk about numbers. AB is the length of 4. Okay? And CD is the length of 6. Now, we're going to make line AE, okay, the length of 2, and the line CF the length of 3. Let's go through this. AB is the length of 4. CD is the length of 6. AE is going to be the length of 2, and CF is going to be the length of 3. Why is that? Because as 4 is to 6, so is 2 is to 3. Because if you reduce 4/6 down to its lowest common denominator, you're going to have 2/3. 2/3 equals 2/3. And that's true. Okay. Now then, I say the remainder EB. Now what is the remainder EB? Well, if you do any arithmetic at all, you would know that if you subtract 2 from 4, you're going to be left with the number 2. Okay? Because AE is 2, AB is 4, and if you subtract 2 from 4, you'll get 2. I say the remainder EB is also the same parts of the remainder FD. Okay. What is FD? Well, we said the CD is 6, and we said CF is 3. Well, 6 minus 3, of course, is 3. So, EB, which is 2, is to FD, which is 3, as AB, which is 4, is to CD, which is 6. Now you say, well, that concludes everything. No, 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 no. That's what we're trying to prove. Okay? For let GH be made equal to AB. That's why we have this third line. See this third line right here? We have GH. And it's going to be the same length as AB, so this is also going to be 4 inches long. Okay. Therefore, whatever parts of GH is to CD, the same parts also is AE of CF. Now, if you're scratching your head at this point, let me translate that for you. GH, of course, is 4, and CD is 6. And AE is 2, and CF is 3. So as 4 is to 6, so as 2 is to 3. But we're not done yet. Let GH be divided into the parts of CD. Okay? we're going to divide GH into two equal parts. And GK and KH are going to be those equal parts. GK is going to equal 2. KH is going to equal 2. Okay? And we're going to divide AE into two equal parts. And those equal parts are going to be AL and LE, and they're going to be 1 apiece. So we're going to divide the line GH here into two equal parts. And I said they were going to be GK and KH. And we're going to divide again. I think it's AB if I recall. No, it's AE. We're going to divide AE. Sorry. We're going to divide AE here, right here, AE, into AL and LE, and they're going to be 1 apiece. Hope I haven't lost you yet. Let's keep going here. Thus, the multitude of GK, KH, which is, you got two parts there, will be equal to the multitude of AL and LE, which you got two parts there. Now, since whatever part GK is of CD, well, what's GK? Well, it's 2, and CD is 6. The same is also of AL to CF. Well, what's AL? 1, and what's CF? 3. So as 2 is to 6, then 1 is to 3. While CD is greater than CF. Well, CD obviously is 6, and CF is obviously 3, and CD is definitely twice as long as CF. Therefore, GK is also greater than AL. Well, GK is 2, AL is 1, so 2 is greater than 1. Let GM be equal to AL. GM, way over here, is going to be the same length as AL, which is 1. Therefore, whatever part GK is of CD, well, GK is 2, CD is 6. As 2 is to 6, the same part as GM is to CF. What's GM? Well, GM is 1, CF is 3. As 2 is to 6, so as 1 is to 3. Therefore, also the remainder MK. Well, what's MK? MK is 1. Okay. It's the same part of the remainder FD. Well, FD is 3. Okay. As 1 is to 3, then the whole GK, which is 2, is to the whole CD, which is 6. As 1 is to 3, so as 2 is to 6. And this is by Euclid Book 7, proposition number 7, which we covered in the previous video. Again, since whatever part KH is of CD, okay, KH is 2, CD is 6. Now, I want you to continue studying your diagram as I continue reading these things off to you. As 2 is to 6, the same part is EL to CF. Well, what's EL? EL is 1, CF is 3. As 2 is to 6, so as 1 is to 3, which is true. While CD is greater than CF. Well, CD, we've already established 6 is greater than 3. Therefore, HK is also greater than EL. Well, what's HK? Well, we said that HK is 2 and EL is 1. Well, 2 is greater than 1. Let KN be made equal to EL. Well, here's KN right here, and we're going to make it equal to EL. Now, EL is 1, so KN is also going to be 1. Therefore, whatever part KH is of CD, well, what's KH? It's 2, CD is 6. The same part also is KN to CF. What's KN? It's 1, CF is 3. So as 2 is to 6, so as 1 is to 3. We already established that. Therefore, also the remainder NH. Well, what's NH? Well, that's going to be 1. Is the same part of FD. Well, what's DF? That's 3. So as 1 is to 3, as KH, well, KH is 2, and CD is 6. So you have as 1 is to 3, as 2 is to 6. And again, that's Euclid by Euclid Book 7, proposition number 7. But the remainder MK, well, what's MK? It's 1. Was also proved to be the same part of the remainder FD. Well, what's FD? FD is 3. As 1 is to 3, that the whole GK, that's 2, is to the whole CD, which is 6. As 1 is to 3, then 2 is to 6. Very good. Therefore, also the sum of MK and NH. Well, what's MK? 1. What's NH? 1. What's 1 plus 1? 2. Is the same parts of DF. What's DF? 3. So now we have as 2 is to 3, okay, that the whole HG. Well, what's HG? Okay, that's 4 is to the whole CD, which is 6. So as 2 is to 3, then 4 is to 6. We got that. But the sum of MK and NH is equal to EB. Well, what's MK? 1. What's NH? 1. What's 1 plus 1? 2. What is EB? Well, EB is 2. So we've said the sum of MK and NH, which is 1 plus 1, that's 2. It's equal to EB, which is also 2. And HG is equal to BA. Well, what's HG? Well, GH is 4, and AB is also 4. Therefore, the remainder EB, which is 2, is the same parts of the remainder FD, which is 3. As 2 is to 3, that AB is a CD, as 4 is to 6. And that's your proof. Now, why they gave all this, I really don't know, but it is Euclid's algebra, and now you know it. What a long proof, huh? All the numbers worked out, though, so that's the good thing. First time I did this, the numbers didn't work out so good, so I had to redo it. The numbers work out. You can check them out for yourself. I will tell you more in a future video. Stay tuned.